Day 64 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. But you already knew that because we here every day doing LeetCode problems. So I know you're not surprised. And I hope you guys are staying motivated, staying disciplined to learn this stuff and continuing to learn and embark on your coding or programming journey, guys. So with that being said, don't forget, guys, bring your mouse right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me, guys. And then after you smash that like button, you know what I need you to do. I need you to go into the comment section, and I need all of my bankers out there to go ahead and drop that bank emoji in the comments so we can run this engagement up and we could bring more awareness to the Swift community as a whole and get more people interested in learning Swift so that it doesn't go obsolete. You know what I'm saying? Now, with that being said, guys, we had the part you all been waiting for, the question. And today we have question number 2,336, smallest number in an infinite set. The difficulty level is medium, but you guys already know we're going to keep the solution as simple and easy to understand as possible because we're all here trying to learn, and there's no sense in trying to code something and we don't understand what it is that we're coding. So that's why we're going to keep this answer as simple and easy as possible. And now let's get on with the question. It says you have a set which contains all positive integers 1, 2, 3, 4, 5. Implement, but all of them. Remember, an infinite set. So, then it says implement the smallest infinite set class. Smallest infinite set initializes the smallest infinite set object to contain all positive integers. Pop smallest removes and returns the smallest integer contained in the infinite set. Void add back int num adds a positive integer num back into the infinite set if it is not already in the set, guys. So let's see how we're going to do this. This is really not that difficult. The question is a little hard to understand, but that's why I'm here. I'm going to break it down to you guys. So first, we have the example 1. We have the input. These are the inputs. We're just calling the different functions, and this is what we're working with. The output. This is the output. Null 1, 2, 3, null 1, 4, 5. Explanation. So let's break it down. Let's look at the explanation so we can break down exactly what's going on here and how they're getting these numbers in the output, right? So first thing it says smallest infinite set equals new smallest infinite set, right? So first thing we're just doing is we're creating the new smallest infinite set, which is why this one is null. This right here, that's why this returns null right here, because we're just creating the new set, the new smallest infinite set that we're going to work with going forward, right? So then we come right here. It says add back. So now we're adding back, right? Smallest infinite set, add back 2, right? But 2, here says 2 is already in the set, so no change is made, right? So remember, we have the infinite set. We haven't removed anything, right? So that's why it's null, because we haven't removed anything. 2 is already there, so there's nothing to really add back, or we're not doing anything because 2 is already there. So that's why we return a null. Then we'll come down here. It says smallest infinite set, pop smallest, right? So now we're right here, pop smallest. Come right here. It says return 1 since 1 is the smallest number and remove it from the set. So remember, we're working with the set. We want to pop the smallest number in the set, and the set is infinite numbers, but the smallest positive integer in the infinite set would be 1. So that's why we're going to remove 1, but we're going to return it as well, because when we pop something, it returns it and removes it. So that's why we're returning this 1. This 1 is showing because we're returning it, right? So then we're going to come down. We're going to come over here. We're going to pop smallest again. Then it's right here. So smallest infinite set, pop smallest. We're going to return 2 and remove it from the set, right? So that's why 2 is right here, because we're returning it. And then we're removing it from the set, but we have to return it as well. So that's the 2 that we return, right? Then we'll come over here. We have to pop smallest again. So Oh, excuse me, no, we're right here now. We're at this pop smallest. We're going to pop smallest again. And now we already removed the 1 and the 2 and return it. So now the smallest integer in the set is 3 because we already removed the 1 and the 2, right? So then it says, this is right here. We returning 3 and remove it from the set. So this right here, we returned 3. That's the 3 that we returned, and it's removed from the set, right? Then we're coming back here, smallest infinite set, add back. Or excuse me, we're right here in the input. Right here in the input, and then we're right here in the example. It says smallest infinite set, add back 1. 1 is added back. 1 is added back to the set. But remember, so this says no because remember, we're not returning anything. We're just adding it back to the set. So we don't need to return anything. So that's why this is null, because there's nothing to return, right? We're just making sure that it's back in the stack or in the set, excuse me. Then we come back over here. Now we're right here, pop smallest again. Now we're pop smallest again. Pop smallest, we're returning 1 since it was added back to the set and is the smallest number, and then we remove it from the set. So look, this is the 1, we returned it, but now it's not in the set anymore, but it's right here because when we popped it and we returned it right here. So now 1 is out of the set again. Now, where we at? We are right here. We're at this pop smallest, right? So then we come down here, smallest infinite set, pop smallest, return 4 and remove it from the set. So boom, this is right here. We returned it, but remember, it's removed from the set. And remember, we already removed the 1, 2, and 3. That's why 4 is the smallest, and that's why we're returning the 4 as well, because we popped it, and when you pop it, you return the small. You return whatever you popping and remove it. So now we're right here, the last pop smallest. We already removed every number 1 through 4. That's why smallest infinite set, pop smallest, we return 5 and remove it from the set. That's where this 5 comes from, because we returned it and now we removed it from the set, right? So I hope that makes sense to you guys. If there were more numbers, if there's a 6, then we would return a 6 and remove it. Or if we added a 4, we would just add the 4, but we wouldn't return anything. Excuse me. But this output is a list or an array of integers or elements that we are returning. If we're not returning anything, then it's going to be a null. Remember that. That's where these nulls come from, because nothing was returned. Even if we add something, we're still not returning it. We're only returning it if we popped it. In this function, if we popped it, then we return it. If we didn't pop it, then we're not returning anything. And that's where these elements come from, everything that we have returned. So now that we understand what the question is asking, let's go ahead and figure out how we are going to code it. So the first thing we're going to do is we are going to declare a variable, and we're going to call that added, and we're going to cast that as a set, and then we're going to open up these greater than, less than brackets, and we're going to put an int right in between the middle of those. And then we're going to say equal, and it's going to be an empty set. Now this right here, this is us initializing it, so we don't have to initialize it right here because it's initialized right here. And we're going to do the same thing for declare another variable, and we're going to call this popped max, and we're going to cast this as an integer, set that equal to 0. And this is initializing it again as well, or this whole line is initializing pop max, and this whole line is initializing added, so we don't have to initialize anything right here. Then we're going to come down here and we're going to say if let smallest is equal to added dot min. So that's going to give us the minimum or the smallest number in added. Then we're going to say comma smallest is less than or equal to popped max. Then we're going to come down here and we are going to say added dot remove smallest, and that's going to pop the smallest integer in the set for us. Then we're going to come down here and we are going to return smallest, because remember, when you pop something, you remove it and return it. You don't just remove it. You have to remove it and return it to pop it. And then we're going to come down here and we're going to say else popped max plus equals 1, and we're going to come down here and return pop max. But that's important to understand, that when you pop something, you're returning what you popped, as opposed to just removing it and just not returning it anyway. So then we're coming back to add back, and add back, we're going to say if num is less than popped max, then we are going to say added dot insert num. Then we're going to come down here and we're going to say else if, we're going to say else if num equals popped max, we're going to say if added dot contains num, then we're going to say added dot remove num. Then we're going to come down here and we're going to say popped max minus equals 1. So if you notice here in the add back, we're not returning anything. You see, we removed it, but we didn't return anything back, and that's why we're going to say no when we call the add back function, because we're not returning something. And when we come to the pop smallest function, we're going to return whichever the smallest number integer was that we popped, because we're returning it. We're returning it right here. So remember, when you pop something, you have to return it after you removed it. Whereas when we're adding something or inserting, in this case, whether we're inserting it or removing it, you see we're not returning it, and that's why the outcome is none, or the output. That's why the output would be null, because we didn't return anything. We just called the function, but that function doesn't return any values, so we're going to put null. Whereas this function, when we call it, it returns either the smallest or the pop max, and whatever that's going to be is right here. So remember that, guys. When you pop something, you have to remove it and return it, as opposed to just removing it, guys. Now that we understand that, let's run it and see how it goes. Let's see, guys. Ooh, okay. We got a typo, small little typo. Nothing to get nervous about. Oh, excuse me. Now let's run it again and see what happens. Let's see what happens. Let's see, guys. And it's accepted, guys. So let's submit it and see what happens when we submit it. Because sometimes it might get accepted when you run it, but not when you submit it. But this got accepted both times. Ooh, 156 milliseconds beats 14.49% of users with Swift. Yeah, we got to get that up, guys. But like I said, we're here to learn, and I hope you all understand the solution and what the question is asking, because if you don't understand what the question is asking, I doubt it's going to make it just harder on yourself to understand what the solution is doing, right? So I think this is a good solution to understand what's going on and to learn about popping things and inserting things. So yeah, guys, I'll see you guys tomorrow for another day, another LeetCode problem. Peace.